Here we are. Cool. Hey Hacksters, welcome to Monday, and today's edition is very fun. I am doing a mailbag, I don't know, sharing check video thing. Anyway, I got some cool stuff. So first off, I got this package from Bubblesort Zines, which is run by Sailor Mercury, whom you can find on Twitter. She's an awesome person who publishes these zines that teach you how to do things like send secret messages with computers, how arrays work, how does the internet, and things like that. So if you're curious about how different hardware and software things work, you can find some cool explanations with cartoons and everything. IMO, it's a fun way of learning. And if you've ever looked at, what's that weird one for Ruby? Wise Poignant Guide to Ruby. In my mind, it's that same vein of like entertaining, interesting, visual, learning for people who don't have a hard time like focusing on dry textbooks. Plus she has a bunch of really cool other cute tech stuff. For example, she's working on some pastel colored alligator clips, which I think is just rad. Not obviously my color scheme, but cool that it exists. Next up, we had a visit from Matt from Bare Conductive last week, Matt Johnson, and he left us with this cool, let me get this in focus for you. It's a cool pin that I surmised can also work as a touch controller sensor thingy. The thing is, it comes with this little pin that you can use to make it a lapel pin, but it doesn't have any indication as to how it's actually attached. So I'm kind of deciding whether to do it like this. I like that. That's cool. Or I could do it like this and it's kind of mysterious. And I'll probably decide on that later. Maybe do that at the end. And finally, other people have already gotten these and shared their solutions, so I'm assuming it's fine to go ahead and solder this on the air. It's the most recent offering from the Boldport Club, which I finally joined. We actually did I did an interview with him and got to visit the factory while these were being packed by a student from the art college, and so I'm really excited to see it show up in my own mailbox. So let's open this up. And we're gonna put it together on the air so you can witness the glory of, oh, it's so pretty. Look at this in like the full glory here. Oh, it's so gorgeous. The Monarch, it says, in collaboration with Euro Circuits. One of the cool things about this, as we discussed in the interview, which is upcoming probably next Tuesday, I keep pushing that back because there's a lot to transcribe. But in the meantime, we'll have other cool cafes for you. Yeah, the cool thing about this is that, one cool thing, you've got the little packaging things poking out. And we talked about how that is like a little sort of inviting thing that makes you want to open it up and see what's inside. Let's see if I can do this without totally wrecking the paper packaging. No! It's caught! Come off! No, I'm not gonna be able to do it. Okay, let's just peel this off here. Yeah, I saw one version of this that had been printed on just the local laser jet, and this is done by a professional printing company. It's really gorgeous. Kind of cool to see behind the scenes there. And then we have this box. I've got this hella zoomed in so that you can see this soldering well, but I'm going to give us a little more altitude. Yeah. How's that? Ah, glorious. Cool. So yeah, here's the box. How do we open? We go like this. Almost really satisfying. It didn't quite come off in one piece. And here we have the Monarch. It looks like it is in its native environment here. This is a beautiful circuit. And I'm going to show you the tutorial that we're going to be following. You can find it as well at boldport.com/monarch. Okay, so this thing has some cool properties. If you shine light through it, it will shine through, so it's kind of translucent, because there's places where there's no copper in between, and no solder mask, really. I mean, there is solder mask all over it. This red is all solder mask. Let's see if I can get a better Does that show up? Yeah, so you can see the like design through there. It's pretty cool. All right, so while we put this together, I'm going to tell you a little bit more about what we talked about on the interview, but there's also some cool other stuff to do with this. Let's get started. They intentionally included like several different colors of grass in this, so it would look more naturalistic. I saw they had like a ton of different colors in the office. It was kind of funny. Little samples of different colors. They really put a lot of thought into the design of this. The nice thing about this thing is that you have mostly all the same resistors, and then just 3 of another type. Let's see, what are these? 1, 0, 3. Orange is 3, right? Whoa, where did all this gunk come from? It must be from this anti-static stuff. Yeah, here we go. Brown, red, orange. Yeah, so orange is 3, so that means 1, 0, 0, 0, 0. These are 10k ohm resistors. Cool. Then these other guys. Oh, I'm gonna have to remember. Okay, so was it brown, red, orange, yellow, green, blue, violet? Okay, so green is 5, blue is 6. So that's 5, 6, and then 1, 0, 560 ohm resistors. That's these guys. Green, blue, brown. I still have to count resistors on my fingers. It's okay. I'm assuming that's right as well. It's possible it's wrong. Then we've got a bunch of LEDs that are all the same as far as I can tell. We've got a couple of little capacitors. Let's see, are these the same? 105, 105. Cool. I learned that capacitors are counted much the same way, but they give their value in picofarads. So, yeah, this is 10, wait, no, 1 million picofarads, which I'm not sure exactly what that equates to, but you can look it up easily. Scientific notation is not my forte. Then we've got a coin cell battery holder. We've got some wire. This is not solder wire, this is just regular wire. You use this for the antennae on the butterfly. There's also, well, we'll get there. And then we have a little switch. Then a few sockets and ICs. So I'm going to zoom in a little bit more here. There we go. What we have here are shift registers. More specifically, they are linear feedback shift registers, and I'm going to show you the site for this, as well as, there we go, as well as the diagram that we'll be following. So here is boldport.com/products/the-monarch. And it'll tell you all about how this thing works, the components, and well, I really love this diagram over here on the right because it kind of resembles the whole life cycle of a monarch butterfly diagram. I grew up in Kansas for a while, and monarch butterflies were a huge thing for us. One year we actually raised them from eggs through, the chrysalis stage all the way to becoming adults, and then we released them. And so the fact that this is a monarch butterfly really kind of brings a lot of memories back. And then there's like information about it, open source, and how you can buy it. So you can actually buy this yourself if you become a member of the Boldport Club. All right. And then next up, this is a zoomed in version of that image that I showed you earlier. And this is what I'm going to be following. I'm not going to keep it up on the screen. You can have a look online if you want. And yeah. And I'm going to just keep this off the screen so that I can keep showing you what I'm actually doing with my hands. Okay, cool. So the main thing, I guess, is going to be to remember where those 3 main resistors go, the 3 different ones, because there's mostly all the same. Okay, so step 1 is break the 2 halves apart and remove the excess tabs. One really cool thing about this PCB is that it actually is designed to be broken and put together again in this sort of tilted shape so that it actually resembles a butterfly. I'm gonna cut these off with my side cutters. I'm really just snapping them off. And they're perforated. So here we have this. What do we do next? Place the 3 IC sockets. Small lines indicate the position of pin number 1. Okay, and when they say the small lines, they mean these little guys here. Doop, doop. Cool. I think the next step is to solder them on, leaving a gap between the solder and the socket and the board. So that's going to be a little interesting. I'm curious about different methods I could use to keep a gap between the sockets and the boards. Last week we assembled another Boldport Club project, the MOSTAP, and noted how sockets, like ICs, have an indicator for pin 1. This one is actually fun because they use 2 different indicators. You see this little dot here indicates pin 1 of this 8-pin chip. And then for this 14-pin one, they've got a little divot over here. Same for this guy. So those are all indicators of pin 1, and they're also matched by little dips in the sockets themselves, so you can easily remember which way to place them. So going by the diagram about where pin 1 goes, we're going to put this divot down. Dip, dip, dip. Then our longer socket goes like this. Down again. Whoa! So sometimes with jumper wires or with sockets, if you push too hard on the pin, you'll get it coming out the other side, and that's what's happened here. I'm just going to push it back. There we are. Got these pins coming through on the other side. Cool. Glorious. And then this one has pin 1 facing up. All right. Gorgeous. And this is gonna go like that in the end. So I think I'm just gonna keep that gap like this. I'm gonna turn my soldering iron on, and I'm gonna quickly tack, or what do you call it? My vocabulary is going. Tack solder, there we go. Tack solder a couple of pins from each of these sockets so that they hold them in place. And then I'll go through and solder the rest of them with it clipped into the 3rd hand, just to make sure that everything's all nice and pretty. I've got my arm on my solder, and I'm just waiting for the soldering iron to heat up here. Let's take another look at where we are. Place the 3 IC sockets. The small lines indicate the position of pin number 1. Now solder the sockets, leaving a gap between the socket and the board. Pins are flush with the board, gap, and socket. He says the pins should be flush with the board, so I guess let's try and make that happen. I think it doesn't matter that much, though. It's all for aesthetics. In fact, I'm just going to kind of leave it as is, I think. I mean, there needs to be space for everything else to go in there, but that appears to be the case already, so that's fine. I am going to go rogue a little bit with another part of this, and we'll see that later. Oh. Let's pull this in here. Tack soldering. Here I'm just using the solder itself as a little self-solderer. Like, it's structural, right? It's a little bit structural, so you can kind of bend it to be however you need. And that way you don't need 8 million hands. It is a little finicky when you're trying to bend around a butterfly-shaped PCB, but that just adds to the interest, right? Okay, one more to go. Ah! Ah! Getting hooked on here. Come on, be my friend. Let's turn it around this way. Still holding it so that everything stays in place. There we go. Okay, now I don't expect these like 6 connections to hold it in place for long, so I'm going to go ahead and do a few more while I'm just holding it like this. Obviously I'm being careful with my fingers and stuff. Only do this way if you're a little bit more experienced. I trust myself not to burn myself, but at the same time, if I do burn myself, it's my fault. And I get to deal with the consequences. I have held soldering projects for kids a few times at hackathons, and let me tell you, that is a scary experience. I've got a scar or two to prove it, in fact. But, you know, sacrifices we make for the greater good, right? I think this is pretty well attached at this point, so I'm going to go ahead and clip it in the third hand, so I don't have to keep messing around with this solder bending technique. In fact, calling it a technique is a little bit fancy. Okay, here we go. This is going to go faster. There's this really meditative quality to soldering a bunch of connections in a row. I like it a lot. I saw a really cool thing on Twitter recently. I'll link it underneath this video, but someone has created a PCB that just has surface solder pads, and you solder on top of them, making little convex beads. And they're in a pattern of Braille. So it creates this tactile PCB that's a little DIY Braille sign. I think that's really cool. It's sort of like a crossover of language and art and electronics all in one. The solder connections I don't think are functional, but it's very beautiful. And it's functional in a non-electronic way. It's kind of a, you know, related to the concept of how electronics is not separate from culture. Anything you do with technology happens within the context of human culture. There's no separating it. And that leads to a lot of the, like, arguments on the internet and stuff, and elitism in the community. It's important to remember that all that stuff is secondary to being a person. In fact, Micah Scott had a really excellent recent set of tweets about this. Can you tell I spend a lot of time on Twitter? But she talked about how she used to be the Rick, as it were, like from Rick and Morty, in her workplace, and how that really doesn't serve the team and or her in the long run. And so she decided to change and managed to. Okay, have we got these all soldered in? Yes, no bridges, all beautiful. That's quite lovely. If I do say so myself. Anyway, yeah, what's next? Prepare the LEDs. I'll put this up for you while I work on it. So here's an interesting thing. It says you can put the LEDs on either side of the board, and most people have got them pointing up because it's kind of cool to look at, but I like the idea of them pointing down because then in low light it'll look really gorgeous. I love the effect that you get when light shines through the PCB, and so I want the lamp to use indirect light in that way. It's kind of amazing that this whole thing runs off of a coin cell, by the way. That's just nuts to me. Like, it's so low power. Okay, so it says prepare the LEDs. I think it just means like stick them through the holes. Cool. Yeah, awesome. So I've got 6 LEDs here. 1, 2, 3, 4, 5, 6. Oh no, I got how many? 1, 2, 3, 4, 5, 6, 7, 8. Excellent. So I'm going to put these on the underside. I don't think they're going to actually interfere with anything. And the way that he has this set up is that this indicates the length of the leg. So the short leg is going to be your ground leg, and the long leg, as on the LED, is going to be your positive leg. The short leg also corresponds to a flat side on the LED. I'm just checking the undersides of all my solder joints on here to make sure that they're going all the way through and they're going to be strong and stuff. That looks pretty good. But if I have any issues, I'll go back. Bend this a little more and I hope I don't break anything. Stressful. Okay. We're going to stick these on here and solder them in. And again, I'm putting the LEDs on the underside of the butterfly because I think they'll look cooler that way. Oh, go on, go through. Oh, they don't go through. No! I guess, did he tell us that? Yeah, okay. Told us that already. Cool, I'll just cut him. As usual, or rather, at least as with last time, he's got this thing where you have to use the leads, the cast-off leads from the LEDs, as or the resistors as parts of the circuit later on as little jumpers. I think the LED ones are a little stiff for that, but we're going to use the resistor ones, which are more malleable. So that's kind of cool. So, okay, this being the case, since I'm cutting these off, I can't actually bend them outward to hold them in place so that I can flip over the entire circuit board and solder it. Because as you can see, these don't actually go through. There's this these little square nubbins on here that keep it from working. So I'm going to cut these off. Right above the little nubbins. See that? Choo! Sound effects are necessary. Choo! We've done 4. And again, you know, LEDs have 2 indicators of which side is ground and which side is positive. So I'm going to be using the flat side to indicate ground since I'm cutting the legs off. Alright, looks like we're going to do more tack soldering, or like upside random hook soldering, whatever you would call it. There's got to be a name for this, but I'm just going to call it hook soldering, because that's what you do, is make a hook with the solder itself. Okay, so here we have the flat side of the LED. As you can see, there's one round side and one flat side. Hopefully that comes through. Maybe if I hold it like this. Yeah. And I'm going to orient the flat side along the short leg image and then solder it on the other side. I'm just using my finger underneath to hold the LED in place while I solder it. And after I've got the first one done, the second one comes more easily. There we go. Uh-oh, let go too soon. Gotta melt it on again. Melt, 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 melt. Come on. That's better. Okay, beautiful. I'm gonna zoom in a little more so that we can get a better reference on the rest of this. There we go, how's that? All right, more LEDs, more slots. Flat side goes on the left, jump. And we solder using the hook. This does require constant readjustment of your solder because it loses the curvy down piece. That looks pretty good. 2 down, 6 to go. There's some cool stuff about these shift registers. So, as the instructions say, it's an LFSR, which is a... Wait, do I have that right? Linear feedback shift register, yeah. And that means that it can be used as a pseudo-random number generator. And I was like, well, how does that work? How can you have something pseudo-random? And I've heard before of using real-time clocks and as random number generators, and also just a separate chip as an actual like hardware random number generator. And it's like, why is that necessary? I understand that there's like different levels of randomness, but what does that actually mean? In this case, so we have a construction team coming in. So I'm gonna actually stop after these LEDs and I'm gonna come back with part 2 tomorrow. So let's just finish this set of them. And if it gets a little noisy, then it gets a little noisy. All right, so randomness, right? So pseudo-random number generators appear to generate random values, or they generate values that appear to be random to like a casual observer. However, they can be predicted because they're generated from an initial seed value. So they are actually procedurally generated. And that means that they're fairly easy to compromise relatively. Like if you, for example, are doing cryptography, you almost never want to use a pseudo-random number generator because that is too easy to crack if you just have a lot of computing power that can determine the pattern or the initial seed value. Kind of like with Bitcoin mining, it takes a lot of numerical computational effort to crack it, but it can definitely be done. More LEDs. And so there's actual random number generator chips, and how do those work? So usually they use an actual physical component because the natural world is unpredictable. There's a really cool book about chaos I was reading recently, and yeah, it's incredibly difficult to predict. And so they use things like, radioactive particles being thrown off from a material, and temperature values, and like the very last digit of the current time or whatever. Actually, I think that's more of a pseudo-random one. There's all these different ways of generating random data. And for example, there's also a pseudo-random one, or a not very strong random one, let's put it that way, that entails just mashing numbers on a keyboard. But that's predictable, like each person is going to have their own kind of signature, which is really cool. Yeah, randomness. Look it up. It's fascinating. I'm going to be looking it up some more because obviously I'm a complete noob in this area, but it's really interesting. So yeah, like radioactive particles, temperatures, and other data coming off of an actual hardware physical interaction is used to power these true random number generators. And then these guys, the linear feedback shift registers, are used for pseudo-random stuff. It doesn't have to be too crazy. All right, so we've done the LEDs on here. We've done the sockets for the chips. And unfortunately, I have to stop there for today. So, but we had a great time with our mailbag. We saw the beautiful pin from Bubblesort Zines. Go check it out. I think it's bubblesort.io. Sailor Mercury is fantastic. I actually bought this because I'm just excited about it. It's not sponsored or anything. This was just a gift from Matt as he came by. I think they made a few of them and decided to give them out. Super cool. Can't wait to have an excuse to use this in some kind of a project. Tune in tomorrow for the rest of this Boldport circuit, the Monarch. Join the Boldport Club if you want to see more or get your own. And we will be back with more soldering. Thanks for watching. and have a marvelous Mailbag Monday. Yeah.